Topic for this video lecture is 2D projectile motion, and in this part of the lecture we'll cover oblique projectile. So let's first understand what is an oblique projectile. So before this topic we had done one-dimensional motion. In one-dimensional motion also we have studied projectiles. There are three possible cases in one-dimensional motion. One, when object is released from rest, initial velocity is 0. In that case, it moves in vertically downward direction in gravity. Other cases are when it is given a velocity either in vertical direction upwards or vertical direction downwards. In both the cases, again, it will have one-dimensional motion. What gives rise to one-dimensional motion? The velocity is either parallel or anti-parallel to acceleration. So that itself gives a hint about what is oblique projectile. Oblique projectile, the angle between velocity and the acceleration is not 0, not 180. Anything other than 0 and 180, it will give rise to an oblique projectile, which will have two-dimensional motion. So the oblique projectile, what we are going to study, should meet two conditions. One, acceleration must be constant. We are only going to study the case when the acceleration is constant or uniform. In other words, uniformly accelerated motion. And second thing, velocity should be at an angle theta other than 0 and 180. If it is 0 or 180, it becomes one-dimensional motion. So let's see how do we meet the first condition of acceleration being constant. Or in real life, how do we come across a situation when the acceleration is constant and it is close to ideal oblique projectile. The constant acceleration implies constant force. So what is constant acceleration? Since it is vector, there are two things. Its magnitude must be constant and its direction also must be constant. So what is a common example of constant acceleration? When object is moving under gravity, is falling under gravity. So when we talk about object moving only under gravitational force or acceleration, is when object does not have contact with anything else. So only force acting on the object would be that of gravitational force. So in that case, the force will be constant and acceleration will be constant. So for constant acceleration, even air resistance also should be negligible or absent. It should be negligible compared to gravitational force. In that case also, it could be considered close to an ideal oblique projectile motion. So we get close to ideal scenario if the object which is projected is something like an iron or metal spherical ball, which is close to ideal condition. Because it will have large mass, hence large gravitational force, and because of its spherical shape, the air resistance would be much smaller. So how do we define a typical projectile? We define a typical projectile in terms of u and theta, u being the initial speed of projection and theta is the angle measured from horizontal. So a particle is projected at time t is equal to 0 with initial velocity u, making angle theta with the horizontal. Point of projection is considered to be origin. In all through our lecture, we will consider the point of projection to be origin, or initial position of the projectile would be at the origin. And time of projection, we will consider time to be 0. So in case of oblique projectile, both an x and y coordinate will change, giving rise to two-dimensional motion. So what is the objective of our two-dimensional projectile motion analysis? Our objective is to find the position of the object. Our objective is to find the position of the object at any time t after its projection. The position means we need to know its x coordinate as well as y coordinate at any value of t until it hits the ground. That's what. So if we know where exactly the projectile is at any time t, if we know the position, we can find out other parameters like velocity as well. Velocity and directional motion. So how do you go about analysis of 2D projectile motion? So before we start analysis, let's consider an experiment which gives us a good insight into how the analysis is done. So this experiment involves three objects, and all three objects are set in motion at the same instance from origin. What are three objects here? There's one small ball p, which is given initial velocity u at an angle theta with the horizontal, and it will experience a downward acceleration of g. So if we express its initial velocity in terms of components, x and y component, the initial velocity x component will be equal to u cos theta and y component will be equal to u sin theta. X component will be equal to u cos theta, y component is equal to u sin theta for particle P. And acceleration, gravitational acceleration will be downwards. So its y component will be equal to minus g, minus sign because the direction is downwards, and its component in x direction will be 0, or ax will be equal to 0. That's for particle P, shown in blue color. The second particle here is A, shown in yellow color. This is a ball projected horizontally with the velocity ux is equal to u cos theta. So initial velocity of this ball is same as x component of initial velocity of P. So this is also u cos theta, this is also u cos theta. Since projection is in x direction, the y component is velocity is 0. The acceleration of this ball, yellow color ball, also is taken as 0, which is x component of acceleration of ball P. So ball A, the initial value of velocity and acceleration are x component of acceleration and velocity of P. Let me repeat again. So what is the motion of A? Initial velocity and acceleration are equal to x component of velocity and acceleration of projectile P or ball P. The third object is ball B, which is shown in red color. This ball is projected vertically upwards with the velocity equal to u sin theta, and it has an acceleration of g acting downwards. So in other words, the velocity and acceleration of ball B is same as y component of velocity and acceleration of projectile P. So when all three of them are projected at the same instance, so all three are projected at the same instance, initial velocity and accelerations are as given here. What we observe is at any instance of time, the x coordinate of P will be same as x coordinate of projectile A, and y coordinate of P will be same as y coordinate of projectile B. So x coordinate of P identical to A. In other words, the horizontal motion of projectile P is identical to A, and vertical motion of projectile B is identical to particle B. So if I have to find x and y coordinate of P, rather than finding x, y coordinate of particle P, I will find x coordinate of particle A at the same instance, and to find y, I would find the y coordinate of projectile B. It's much easier to find x and y coordinates through projectile A and B, because both A and B are having one-dimensional motion or one-dimensional uniformly accelerated motion, which we know already. So in essence, what we are doing here, we are breaking down a two-dimensional motion of a projectile into two independent one-dimensional motion. So what we are going to do, so whenever we want x coordinate of P at a particular time t, how do you find x coordinate? We find the displacement of particle A in time t. That would be equal to x coordinate, and to find the y coordinate will be equal to displacement of particle B along y axis. So 2D motion can be analyzed as sum of two independent one-dimensional motion. What are these motions again? X motion, the A particle will have velocity and acceleration, which is x component of initial velocity and acceleration of P, and particle B will have initial velocity and acceleration same as y component of initial velocity and acceleration of P. How do you find position vector? So first, position vector. So if we know x and y coordinate of particle P at any instance of time t, we will know the position vector. If x coordinate is x and y, the position vector will be xi cap and y j cap. So to find x coordinate of P, I will find displacement of A in time t. Since initial position is at the origin, displacement will be equal to the position vector at time t. So what would be the x coordinate of particle A in time t? X coordinate of particle A at time t will be equal to displacement of A in time t. How do you find displacement in time t? We find the displacement in time t using the formula s is equal to ut plus 1 by 2 at square. We will apply this formula along x-axis. So along x-axis, u is u cos theta, expression is 0. When we substitute this value, we will find the x coordinate at time t will be equal to u cos theta t. Similarly, y coordinate of P will be equal to displacement of B in time t. So y coordinate of P at time t will be equal to displacement of B at time t. How do you find displacement? Again, in similar manner, displacement we can find using our formula s is equal to ut plus 1 by 2 at square. So this time we will substitute values for particle B along y-axis. So in this case, y will come equal to u sin theta t minus 1 by 2 gt square. Y minus expression is negative. So this way we can find for any value of t, we can find out the x and y coordinate of projectile P, which is having a two-dimensional motion. Next, we can also find out what will be the velocity vector of particle P at any instance of time. Because of presence of acceleration, velocity will keep on changing. So we can find out the value of velocity vector at any instance of time t. How do you find velocity vector? We separately find x component and y component. So x component of velocity at P will be same as velocity of A at time t. X component of velocity at P will be same as velocity of A at time t. So Vx will be equal to velocity of A at time t. How do you find velocity of A at time t? We will find using the formula V is equal to u plus at. We substitute the values, A being 0. The velocity of P in x direction at time t will be equal to u cos theta. What we find? There is no t term here. It means velocity in x direction is independent of t, or it is a constant. So this x coordinate along x-axis, the particle P will have a uniform motion. Uniform motion means it will move with a constant velocity along x direction. X component of motion will be uniform motion. Similarly, we can find, so this is wrongly written, take it as Vy. The y component of velocity of P at time t will be equal to velocity of B at time t. Velocity of B at time t. What will velocity of B at time t? Again, using formula V is equal to u plus at, we can find out velocity of B at time t will be equal to u sin theta minus gt. So what we find, initially the value of velocity is positive. With time it will keep slowing down until it becomes 0, which is the highest point in y direction, and then it will turn back and it will have a downward velocity. It will start falling downwards and pass to the initial point of projection, as in case of one-dimensional motion in vertical direction. So this is x component, this is y component. What is the angle the velocity will make at any time t? Since y component is changing, the angle also will keep on changing. So we know for any vector, tangent of angle made by a vector with horizontal is also always equal to y component divided by x component. So tangent of angle made by velocity vector with horizontal, tan alpha will be equal to Vy by Vx. We substitute the values, it will be equal to u sin theta minus gt divided by u cos theta. So this term will keep on decreasing with time, hence the angle also will keep decreasing with time. When it reaches at maximum value of y, this term will become 0, or at the highest point velocity vector will become horizontal, and then it will turn negative. Velocity vector will make negative angle with the horizontal. We would also like to know, again, two-dimensional projectile is something like throwing a ball. You would like to know how high the ball will rise when we throw it, or what is the maximum height it will achieve. So let's first understand how to define the maximum height. in mathematical terms, how do you mention what is the maximum height? So which direction are we talking about? Height is, we are talking about motion along y-axis. So when we talk about, when we have to find maximum height, which direction motion we are concerned with? We are concerned with motion along y-axis. So maximum height will depend on the motion along y-axis alone. So height, maximum height in a way, what is the maximum height imply? Maximum height implies displacement along y-axis till the instance velocity in y direction becomes 0. So maximum height is achieved when the velocity in y direction becomes 0. Because as long as velocity in y direction remains positive, it will keep moving up. It will stop going further upwards when the velocity becomes 0. So condition for maximum velocity is instance when y component of velocity becomes 0. So which 2 points are relevant here? Initial point and the final point is the point where velocity in y direction is 0. How do you find this maximum height? We can find the maximum height at this point. Initial point velocity is known, final point velocity is known, acceleration is known. Hence we can use the formula v square is equal to u square plus 2as for particle b along y-axis. Here v will be equal to 0 for maximum height. We substitute these values and we find h is equal to uy square by 2g, or uy being equal to u sin theta, maximum height is equal to u square sin square theta by 2g. So what we notice here, maximum height depends only on the y component. The x component does not figure here. The maximum height is a function of y component only. So if you have two different projectiles, both have same y component but different x component in initial speed of projection. If y component are same, the maximum height reached by both the projectiles will be equal. Or if two projectiles reach same maximum height, the y components must be equal. Then we come to time of flight. What exactly mean by time of flight? If we look at the motion, yes, time of flight is something whether we can understand the time of flight is when the particle hits the point C or particle hits the ground. So again we look at how do we define the particle hitting the ground. Particle hitting the ground, what is the condition when the particle hits the ground? So in mathematical terms, when it hits the ground, the y coordinate will be equal to 0. That's a condition. What is time of flight? Time of flight is time when y coordinate is 0 or displacement in y direction is equal to 0. So again to repeat, what is time of flight? Time taken for displacement in y direction to become 0 is my time of flight. So again in this case, which direction is relevant? Only the motion along y-axis is relevant. So which equation we use? What we know here, for initial point and final point, the displacement is equal to 0 and we want to find out time. So which equation you should use? You should use an equation which has displacement and time, which is s is equal to ut plus 1 by 2 at square. What is s here? Displacement along y-axis, s will be 0 and time will be equal to time of flight. We substitute these two values in this equation, we get the value of time of flight equal to 2u sin theta by g or 2uy by g. That's the time of flight. So time of flight, so what we notice here, even the time of flight also is a function of only y component of velocity. It does not depend on the x component of velocity. So time of flight and maximum height depend on motion along y-axis only and uy only. So all three quantities uy, t and h are related. If one of them is given, other two can be calculated. So there could be some question where one of the things are given, other two can be easily calculated. Now let's come to something what we call as range. What exactly we understand by range? So if I throw a ball, if I go to a ground and throw a ball at some angle, how do I define range? Range will be equal to horizontal distance between point of projection and the point where the ball lands. So which direction do we measure the distance along? Of course, you measure the distance along x-axis. So another way to define the range would be range is equal to displacement along x-axis in how much time? During the time of flight. What is range equal to? Range is displacement along x-axis during time of flight. How do you find displacement in time t along x-axis? I use the formula s is equal to ut plus 1 by 2 at square and apply it along x-axis. Acceleration is 0. Hence, range equal to displacement of x-axis in time t, which will be equal to ux into capital T. And we substitute the value of the time of flight as 2 ui by g. And again, ux is equal to u cos theta, ui is equal to u sin theta. And then in this term also, 2 sin theta cos theta is equal to sin 2 theta. So we get the formula for range. The formula for range is equal to ux into t leads to u square sin 2 theta by g. That's the value of range. That's the formula for range on a horizontal ground. What is u here? U is the initial speed of projection. Theta is the angle of projection. Now, see what we have shown in this diagram. Suppose you have a toy gun which projects a bullet at a constant speed. The speed of projection is constant. You go to an open ground and you fire the bullet at different angle. So once you fire at 15-degree angle, it takes this kind of path, lands here. Then you fire at 30-degree angle, increase the angle of projection, it takes this path and lands here. Similarly, then again you fire at 45-degree, it takes this kind of path and lands here. And similarly 60-degree and 75-degree. So what it shows the path followed by the projectile at different angles of projection with initial speed of projection being same. What we notice here, the range is maximum when angle theta is equal to 45 degree. So let's understand how do we get maximum range. Suppose I want to throw the ball at a maximum distance. What is the angle at which I should throw the ball? So here what we notice, let's understand what is happening here. As theta is gradually increased, as the theta changes, it affects x component and y component of initial velocity. If we increase the theta, y component will keep on increasing. As the y component increases, the time of flight increases. So as this angle keeps increasing, it will remain in air for longer and longer period. So this is increasing order of time of flight. But as the time of flight increases, as theta angle increases, the x component of initial velocity will decrease. As the theta increases, the x component of velocity will decrease. So one term increases, one term decreases. And range is product of both the quantities, and the product is maximum when theta is equal to 45 degree. We get maximum range. In a simpler terms, we can look at this formula for range. If initial speed of projection is same, only quantity which can vary here is theta. What we can change is angle at which I aim my gun, or angle at which I throw the ball, or angle at which I project the cannon. So if theta is changed, we'll get maximum range when the value of sin 2 theta is maximum. It's a sine function, the maximum possible value of sin 2 theta is 1. So range is maximum when we substitute sin 2 theta is 1, which is equal to u square by 2g. So maximum range for a given speed of projection is u square by g. When is this range maximum? When sin 2 theta is equal to 1. And when sin 2 theta is equal to 1, 2 theta has to be equal to 90 degrees or theta has to be equal to 45 degrees. So that's what is shown here. The range is maximum when the angle of projection is equal to 45 degrees. We also see in this figure, so again just to reiterate, what are these figures? These figures, the speed of projection is same, angle of projection has been changed. So 15, 30, 45, 60 and 75. So progressively the angle of projection has increased. So it shows is path followed by the projectile for 5 different angles of projection for same speed. All 5 will have different time of flight. As the theta will increase, the time of flight will keep on increasing. So let's continue analyzing this figure again. What we notice here, there are some, see in this case at 15 degree, when we project at 15 degree, the projectile hits this point on the ground. When it's projected at 75 degree, again it hits the same point on the ground, though at different time. This will take much lesser time to strike the ground, this will take more time, but finally it lands at the same point. So what we find here for 15 degree and 75 degree, the range is same. Similarly, we find 30 degree and 60 degree also, the range is same. So what makes the range same? So let's understand, if what we notice here, the 15 degree and 75 degree are complementary angles, 30 degree and 60 degree are complementary angles. So when for complementary angle of projection, if one angle is theta, other is 90 minus theta, range is same. Let's see why the range is same. The range depends on which term, only term which varies is sine 2 theta. So if angular projection is theta, this term is sine 2 theta. If angular projection is 90 minus theta, it will become sine 2 into 90 minus theta, which is equal to sine 180 minus 2 theta. Sine 180 minus 2 theta is also equal to sine 2 theta. So this term is same for theta as well as 90 minus theta, hence the range is same. So for angular projection of 30 and 60, the range is same. For 15 degree and 75 degree, range is same. Similarly, for 40 and 50 degree, the range would be same. We also notice the maximum height also keeps on changing. Here what we notice, the maximum height at 15 degree, 30 degree, 45 degree, 60 degree, 75 degree keeps on increasing. Let's say H1 and H2 are maximum height reached for angle theta and 90 minus theta, complementary angles. So which two height we can take here? Either we can take H1 for 15 degree, H2 for 75 degree, or we can take H1 for 30 degree and H2 for 60 degree. So H1 and H2 are maximum height reached for two angles of projection which are complementary in nature. In that case, what will value of H1? H1 will be equal to u square sine square theta by 2g, and H2 angular projection will be 90 minus theta. So H2 will be equal to u square sine square 90 minus theta by 2g, or 90 it will be equal to u square cos square theta by 2g. So we add both the values, H1 plus H2, sine square theta plus cos square theta becomes 1. Hence H1 plus H2 comes equal to u square by 2g. For given speed of projection, this is a constant, and this is equal to u square by 2g is equal to maximum range divided by 2. So H1 plus H2 for which is maximum height for two complementary angles of projection is a constant, and it is equal to half the range. What is the half the range when angle of projection is 45 degrees. So in any question, if sum of maximum heights for two complementary angular projections are known, u can be found. Initial speed of projection can be found. So if you look at this figure, H1 is for 30 degree, H2 is for 60 degree. Both are complementary. So if we calculate H1 plus H2, it will be equal to half the range at 45 degree projection. So it will be value of H1 plus H2 will be equal to half of 20, which is 10 meter. So this one and this one plus sum of these two will be equal to 10 meter. Similarly, if we take the other case, if we take H1 for 15 degree and H2 for 75 degree, again the sum of H1 plus H2 will come equal to half of 20, which is 10 meters. This another interesting thing, as the angle of projection keeps changing, both range as well as maximum height keep on changing. So there will be particular ratio for given angle of projection. There will be particular ratio of range and maximum height. R is range and H is maximum height. How do you find this ratio? We substitute the value of range. Range will be equal to, we can write as 2 u square sine theta cos theta by g, and H is equal to u square sine square theta by 2g. We substitute this value, we find the ratio comes equal to 4 by tan theta. 4 by tan theta. R by H ratio, where theta is the angle of projection. So as the angle of projection keeps increasing, tan theta will keep increasing, hence the ratio will keep on decreasing. As the theta increases from 0 to 90 degree, this ratio will decrease from infinity to 0. So when theta is equal to 90 degree, it will go vertically up and come down, range will become 0 and h will be as a finite value. The ratio will become 0. And so basically using this term, we can find out angle of projection for any given r by h ratio. For example, when the range is maximum, theta is equal to 45 degree. So this is the case here at 45 degree. This is maximum height and this is the range. What will the ratio of r by h here? In this case, ratio will be equal to 4 because tan theta will be equal to 1. So for maximum range condition, the range is equal to 4 times the maximum height reached. Then we come to next one, a term called trajectory. Let's first understand what does trajectory mean. How do we define trajectory? See, if a projectile is projected from point A, if we mark every single point this projectile has passed through, if we mark every single point the projectile has passed through, we will get a smooth curve. So this is the trajectory. Trajectory marks the path taken by a projectile. But so if we plot, but mathematically, if we have any curve, it can be expressed in form of mathematical equation. The mathematical equation would be a relationship between y coordinate and x coordinate. For like circle, yes, it has an equation. But this also it will have equation which will have a relationship between y coordinate and x coordinate. How do you find relationship between x and y coordinate? If we can find a relationship between x and y coordinate, I'll get equation of the trajectory. So again to repeat, what is trajectory? Trajectory is a mathematical relationship between x coordinate and y coordinate. Let's see how do you find a relationship between x and y coordinate. And x is equal to x coordinate we have seen earlier. X coordinate is equal to u cos theta t and y coordinate is equal to u sin theta t minus 1 by 2 gt square. So if we want to find a relationship between x and y, what we do? We eliminate t. We substitute the value of t from the first equation into the second equation. If we substitute the value of t from first equation to second equation, we get equation is equal to y is equal to x tan theta minus gx square by 2 is u square cos square theta. Let's understand what does this equation indicate. This equation indicates if any point lies on the path of the projectile, the coordinates of that point must satisfy this equation. So if there's any coordinate a, b, let a and b have some value. If a, b point satisfied above equation, then it will lie in the path of the trajectory of the projectile. In other words, if a and b satisfy this equation, if object is placed at a point a and b, then the projectile will go and hit that object. So you understand what is projectile means. So if any coordinate a and b, if we substitute this value in the trajectory equation and equation is satisfied, but both sides are equal, it means if we place an object at that coordinate which satisfied this equation, then the projectile will go and hit that object. Another thing interesting is the direction of velocity. X component of velocity remains constant, but y component keeps on changing. Hence, the angle also will keep on changing, as tangent of the angle from the horizontal is y component divided by x component. So what we notice here, as the projectile keep moving up, the y component keeps reducing, hence the angle made by the velocity with the horizontal also will keep reducing. At the highest point, y component velocity becomes 0, and hence the direction of velocity also becomes horizontal. And this is the point where the magnitude of velocity or speed also is minimum. X component is not changing, so speed becomes minimum when the y component becomes 0. And after this, again, velocity in y direction becomes negative, hence the angle made by the velocity vector with the horizontal also turns negative. and when the projectile hits the ground, the y component of velocity is same in terms of magnitude as the initial point of projection, but opposite direction. So if theta was the initial angle of projection, when it hits the ground also, it makes an angle of minus theta with the horizontal. Magnitude of angle remains same. So can we find a equation for the direction of velocity? Yes, the tangent of angle made by the velocity is equal to y component divided by x component, which is equal to u sin theta minus dt divided by u cos theta. So what is Vy is equal to dy by dt. What is Vx is equal to dx by dt. So if you cancel both the terms, the tangent of angle made is equal to dy by dx. Let's understand what is this dy by dx. Dy by dx is nothing but slope of the tangent drawn to the trajectory of the projectile. So at any point, if we draw a tangent to the curve, the direction of the tangent would be along the direction of velocity. So dy by dx is the slope of the tangent drawn to the curve at any point. So tangent drawn at point B will indicate the direction of velocity at point B. Tangent drawn at point D will indicate the direction of velocity at point D. That's the direction of velocity. So we have seen angle will keep on decreasing, becomes 0 at the highest point and then turn negative, hit the surface at the same angle minus theta. And also if we pick up 2 points which are at the same y coordinate, if we pick up 2 points at the same y coordinate, we know from one-dimensional motion that at same height the velocities are equal but opposite in direction. So if we take 2 points at the same height, Vx same, Vy magnitudes will be equal, direction will be opposite. Hence, at same height, these angles made by velocity with the horizontal are equal and opposite. One is if plus alpha, other will be equal to minus alpha. Another interesting type of question what we come across is a projectile grazing the top of a pole. What is this grazing means? So let's say, there's a pole, height is h. So if the question is where should the pole of height be placed so that the projectile projected at velocity initial speed u at angle theta just grazes it. Grazing means the closest distance of the projectile from the pole is close to 0. So it almost touches the pole without deviating from its path. In mathematical terms, the coordinate, if the projectile grazes the pole, the coordinate of the top point of the pole would lie on the trajectory of the projectile. What is the condition for grazing? If a projectile grazes any object, then the coordinate of that point will satisfy the equation of the trajectory of the projectile. So here, suppose you have to find where should I place this, what should be the position along x-axis of the pole of height h so that the projectile just grazes it. In that case, if the position is x, the coordinate of the top of the pole will be equal to x coordinate x, which is to be found, and y coordinate equal to h, and this must satisfy the trajectory equation. Equation of trajectory is y is equal to x tan theta minus gx square by 2 u square cos square theta. So if we substitute this value of this x and h in this equation, it will give two values of x. What are those two values of x? Two values of x will be two positions of the pole along x-axis, x1 and x2, where if the pole is placed, the projectile will just graze it. So let's say if the projectile is projected from this point A, initial point of projection, it moves, it will just graze the top of the pole placed at distance x1, it move further. Again, it will, if the second pole is placed at a distance x2, and if this x2 satisfies this equation, it will again just graze, or it will pass at a almost zero distance from the top of the pole on its motion. So during the motion, suppose when it is passing this point P, we record the time which is equal to T1, and similarly when it is passing the point Q, we record the time T2. Of course, T2 will be greater than T1, and T2 will be greater than T by 2, and T1 will be lesser than T by 2. If let T1 and T2 be the time when projectile passes 2 point P and Q. And what is notable here, if it is same pole, heights are equal. Other words, what he is saying, yeah, so if T1 and T2 are the time when it passes through points P and Q, which are at the same height, then what we notice here, the time taken for the projectile to move from point Q to C will be same as time taken by projectile to move from A to P, which is T1. Time taken to move from A to P is T1. So what will the total time taken from A to C will be equal to time taken from A to Q, which is T2, plus time taken from Q to C, which is T1. So total time taken to move from A to C will be equal to T1 plus T2, and time taken to move from A to C is nothing but time of flight. So T1 plus T2 will always be equal to time of flight. How do we make this statement in general terms? Sum of the time when a projectile passes through 2 points at equal height, or sum of the times when y coordinates are equal, is equal to time of flight. So what are the x coordinates of these 2 points where y coordinates are equal? One is x2, second is x1. So suppose the position of 2 poles are given and time t1 and t2 are given. In that case, the distance between 2 poles is x2 minus x1. And how much time does it take to travel from here to here? The time taken to travel from point P to Q is t2 minus t1. And horizontal distance is x2 minus x1. Hence, x2 minus x1, distance between poles or distance between points at equal height, will be equal to t2 minus t1 into, since we are talking about displacement along x-axis, we take the velocity also along x-axis. So x2 minus x1, distance between the 2 poles, will be equal to t2 minus t1 into ux. So if these two distances are given, time t1 and t2 are given, we can find the x component of velocity. So this ends the part 1 of the lecture. We will continue further with the little more advanced coverage of the same topic, which is inclined plane projectile and projectile fired from a height or some similar question.